Quite often what we want to do is locate a point, and that might be when we're looking at a map, or in this case here we're looking at a suburban block. So for example, we might want to identify how to get to that question mark as quick as we possibly can. We could describe it using roads, but if we're looking from above, what we could do is set up some axes. Now in this case we've got the red axis, a horizontal axis, and a blue vertical axis. They're not perfectly at 90 degrees to each other because we've aligned them to the roads here. But by using the locations on those axes, we could actually find a reference for our question mark. So for example, in this case, the question mark is approximately located where the C from the horizontal axis and the 4 from the vertical axis match. Let's look at a way at how we can do that accurately in mathematics using what's called a Cartesian plane. Let's have a look at some of the key features of the Cartesian plane. First of all, what we do is we draw two axes at right angles to each other. These axes are shown in the black lines with arrows. The horizontal axis, or what we call the x-axis, is shown here in red. The vertical axis, which is often called the y-axis, is shown here in blue. Before we plot points on the Cartesian plane, we just need to remind ourselves how we do it on a standard number line. We can see here that we've got three numbers, -3, 2 and 4. The red dot for -3 will be located on the left-hand side where the negative numbers are, and we move to the right to find +2, which is in blue, and +4 in green. And of course, as we continue to move to the right, the numbers increase. Let's have a look now how we plot a point on the Cartesian plane. In this case, we've got the coordinates 2 and 4. So how do we go about this process? Well, let's pretend for a moment that we're looking at a building. So what we might do is we might position ourselves at the corner of the building, in this case at the very left-hand corner. And we can see here with the red arrow, we've had to move across horizontally to find the entry point of the building. Once we find the entry point, then we can go up to the position that's been identified in the green oval shape. Perhaps another way to think about it is if you want to move to a floor in a building, you have to walk into a lift before you could go up or down to that particular position in the building. So we always look at a horizontal number first, and then we move to the vertical number after that. Let's look at how it works with our coordinate of 2, 4. The first thing that we do is we identify where 2 is on the horizontal axis. You can see here we've shown that in red and labelled it as the x-axis. So we find the position of 2, just like you normally would do on a normal number line. Now what we're going to do is move in a vertical direction to find the value of 4. And you can see here we've indicated that with a blue dotted line. So we move across horizontally to 2. Now we need to move up or down. Now 4 is a positive number, so that means that we're going to move upwards to match where 4 is on the y-axis. Once we've found the position that's level with 4 on the y-axis, we put a dot. And what we've done is we've indicated where the point 2, 4 is on the Cartesian plane. Now let's have a look where the point -1, -3 is on the Cartesian plane. And it would be wise to pause here to see if you can find it out for yourself and then check with the result that follows. To identify the point -1, -3, we need to move horizontally to find the value of -1 on the x-axis. We then need to decide to move up or down. Now -3 being a negative number means we'll move in the downwards direction, and we do so till we find -3 on the y-axis. When we've found that point, we locate that, and that's our point -1, -3 on the Cartesian plane.